Here's numbers 5 through 8 from the related rate worksheet, where this covers 5 through 8. And this is one example, and they're all pretty much similar. The length L of a rectangle is decreasing at the rate of 5 centimeters per second, while the width is increasing at the rate of 7 centimeters per second. When the length is 6 and the width is W, when the width is 4 centimeters. Find the rate of change of the area, the perimeter, and the length of a diagonal of the rectangle. Now, on some of these problems, just be careful that you read them carefully. I've switched some of these around a little bit, so whenever it's decreasing, the sign is negative. When it's increasing, the sign is positive, but I flipped these around. I might have said that the length is decreasing, while I might say the length is increasing and the width is decreasing, or they might both be increasing. So kind of watch the wording of these. Read them carefully, and remember, if it's decreasing, it's going to have a negative sign. If it's increasing, it'll be a positive sign. That will affect your outcomes. All right, so, and again, you can find those in the homework folder. There's a PDF if you want to just print it out so you can kind of read along. So, I redid this problem, but what happened was I ran out of memory, so I just decided just to go over it again. I ran too long, so I only have 50 megabytes for our website, and this went 56, I think, so I'm just going to redo it rather than edit it into 2 parts. Okay, so and sometimes I edit them in 2 parts. If you see an abrupt change, or abrupt stop and start, that's because I had to edit it. So if you see an A and B, I probably broke it up into 2 videos. Okay, so I wrote down my data. This is my dLdt was, since it was decreasing, was negative. It was 5 centimeters. L is 6. And dWdt was 7. It was positive. It was increasing. So that's why it's positive, and that was when W is 4. And we're looking for dAdt, to change the perimeter, dPdt, and the diagonal, dDdt. I'll do a sketch over here. And these are my relationships, and I know my diagonal is in a right triangle relationships with the length and the width, so I know that d squared equals L squared plus W squared by the Pythagorean theorem. All right, so first of all, we're looking for dAdt, so I better write down the formula for the area, and the area is length times width, but I want dAdt, so I'll take the derivative implicitly with respect to t. So dAdt equals, and I need to use the product rule, so the first times the derivative of the second, which is dWdt, by the chain rule as well as implicit differentiation, plus the second, which is W times the derivative of the first, which is dLdt. So we're using implicit differentiation, we're using the product rule and the chain rule. Okay, and then we just substitute our data in. So L is 6 and dWdt is 7. All right, so L is 6 and dWdt is 7, and W is 4 and dLdt is negative 5. 6 times 7 is 42. 4 times negative 5 is negative 20. 42 minus 20 is 22, so it's 22. And since it's area, it's going to be centimeters squared per second. And then over here, we want to find the perimeter, dPdt, so it's our write the formula for the perimeter, which is 2L plus 2W. Then we'll take the derivative of both sides implicitly with respect to time. So dPdt is 2 dLdt plus 2 dWdt, and then we just substitute in. dLdt was negative 5, and dWdt was 7, so substitute those in. And that's negative 10 plus 14 is 4 centimeters per second, because that's a linear measurement perimeter. And then finally, we want to find the diagonal. So we know the diagonal, we want to find dDdt. So we want to find, first of all, write the formula for the diagonal. And we know the diagonal equals the square root of L squared plus W squared, because again, we have that Pythagorean relationship that d squared equals L squared plus W squared. So we just know that d equals plus or minus the square root, but we're going to be talking about a length, so we always use the positive square root. Then we take the derivative, so we're going to use the formula for the square root. We know the derivative of the square root of x is 1 over 2 times the square root of x. And if for u, it's 1 over 2 times the square root of u. It's the square root of u times du dx. So you have to apply the chain rule. So it's going to be, this is my derivative, 1 over 2 times the square root of this. So we take the derivative of the outside function, leave the inside alone, and then take the derivative of the inside. So this is again a composite, so this is an application of the chain rule. And the derivative of L squared is 2L dLdt plus, and the derivative of w squared is 2w dwt, because again we're taking the derivative implicitly with respect to t. And then we just have to substitute all of our values in. So L was 6, W was 4. L is 6, W is 4, dL dt is negative 5, and dWt is 7. Hope that all makes sense. And then 6 squared is 36, 4 squared is 16. 2 times 6 is 12, 12 times negative 5 is negative 60. 2 times 4 is 8, 8 times 7 is 56, so that's what we have. Negative 60 plus 56, 36, 16, that's negative 4. That's 52 times 2. I know I've got 4 goes into both these, so I know I'm going to be able to get a 4 out. Now we can simplify. 2 goes into 4 2 times, but 52 is the same thing as 4 times 13. See all these 4 factors of 4, you can see you're going to end up with 4s as a factor. And the square root of 4 is 2, but 2 over 2 is 1, so there's your final answer. d dt is negative 1 over the square root of 13. And that's, again, a diagonal. It's going to be in linear measurements, so that will be centimeters per second. You could carry all the measurements out here, and you'd see that they end up being enough things cancel to put them in centimeters per second. Okay? So take a look at that. You can always go, if I went fast because I already had it written out, you can always pause it, go back, and make sure you follow that. And numbers 5 through 8 will be all similar to this particular example.